All right, Algebra 2 guys, this is 3132. So we're going to start talking about systems of equations and how to solve them. So you need to be able to solve a system of equations by graphing, substitution, and elimination. Well, more substitution and elimination more than anything. So you need to be able to solve systems of equations by substitution and elimination. So let's start off with kind of a problem that you might see. Initial cost for Travis and his band to record their first CD was $1,500. Each CD costs $4 to produce. So it costs $4 to make a CD plus $1,500 to record the music. They're going to sell their CDs for $10 each. How many do they need to sell before they make a profit? So you're starting to compare kind of two equations here. So the cost of the CDs to make. So if it's $4 for each CD, and that's going to be another $1,500 to make the whole thing. That's what that would look like. $1,500 and then 4C after that. Okay, that looks like 1588. I'm going to switch that back. 1,500. So then, what's the equation for the income of the CDs? Okay, so I don't make any initial money off just selling CDs. All I get is $10 for each CD I sell. So, what happens when I graph those two? Well, when I graph them, what does this point represent? Okay, so here's my cost. This one is my profit. Well, what does that represent? $250 and $2,500. Well, what that represents is the point where I break even. All right, so I would have to sell, this band would have to sell 250 CDs to break even. All right, so it would have cost them $2,500 to make that many CDs, and would have cost them, but they also would have made $2,500. So they got to hit 250 CDs before they even make a penny off their music. So that's kind of what we're looking for. So there's three ways to solve systems of equations. One way is by graphing, which we just kind of saw. We see where the two graphs interact. The second one is substitution. Substitution becomes putting one variable in for another and then solving for it and then going back and figuring out what the other variable is. The last one is by elimination. Elimination is exactly what it sounds like. You get rid of one variable and then you solve for the remaining variable and then go back and figure out what the first variable was. So the types of solutions to systems of equations. So one of three things is going to happen. All right, one of three things is going to happen. The easy one is that there's going to be one solution, which we just saw on the previous screen on the graph. All right, so there's going to be, one x value and one y value. All right, there could be no solutions. And no solutions is exactly what it sounds like. And what you would end up is you would end up with something that's completely eliminated. On a graph, it would be parallel lines. So that is going to be completely no solution. So there's going to be parallel lines, and then in the problem, you're going to figure out that there's going to be a mathematical lie. Somehow you'll randomly end up with like 7 equals -3 or something like that. All right, and the last thing is there are infinitely many solutions. And basically what that means is that the line, if it was a graph, the line would be on top of each other, so it would be essentially the same line. And in a mathematical algebra way with substitution and elimination, infinitely many solutions looks like something is always equal to itself. So you'd see like 8 is always equal to 8. All right. So here's kind of what you're looking at. So most of the time you're going to see consistent and independent. You're going to see the lines cross once, there's one solution. That's what I'm looking for. So that means consistent and independent. So then consistent and dependent means same line. If I graph them both, they're both the same exact line, just they look a little different algebraically, but if I graph them, they're the exact same line. That means there is infinitely many solutions. I could pick any point on this line, any x and y value on this line, and it's going to work. So last piece is inconsistent. Inconsistent just means it's never going to cross. It's never going to happen. They are parallel to each other. There is no solution. So let's take a look here by graphing. So I got 2x plus y equals 5, x minus y equals 1. So 2x plus y equals 5. So if I use intercepts, it's easy. So let's say x equals 0, y equals 5. So if y equals 0, x equals 5 over 2, or 2.5. So for this red line, I'm going to be at y equals 5, x equals 2.5. There's my line. For x minus y equals 1, x minus y equals 1, well, if x equals 0, y equals negative 1. If y equals 0, x equals 1. And all I did was put 0 in, literally put 0 in for x and y and solve for the other one. So x is at 1, y is at negative 1. Pretty simple to draw that line. So I'm seeing, where do they cross? Well, it looks like they cross pretty well right there. So what is that function? That function is going to be 2, 1. So let's take a look here. So does this solve both of those? Well, it is 2 times 2 plus 1 equal 5. Check. Cool. Does 2 minus 1 equal 1? Check. Good. There is my solution. Both of those are going to work. So if it's the slope-intercept form, graph the y-intercept first. So what we've got here is we've got 1 in standard form, 1 in slope-intercept form. So you got 5x plus 4y equals 7. And you got y equals negative 5/4 x plus 4. So 5x plus 4y equals 7. So if x equals 0, y equals 7/4. If y equals 0, x equals 7/5. So that is not a very good way to go about doing it, but we can do it that way. For this one, so y equals 7/4, so that's almost 2. I'm going to put it about there. X equals 7/5. That's going to be not quite 1.5. So I'm going to guess it's about there. Now, this one, the second one, it's already in slope-intercept form. I don't have to figure out too much. So you get positive 4, down 5, 1, 2, 3, 4, 5, over 4, 1, 2, 3, 4. There's my graph. Wait a second, something looks weird here. Those two look parallel to me. They look parallel, that means there's going to be no solution. A good way to make sure is let's rearrange this in slope-intercept form. So 5x plus 4y equals 7. So if I subtract 5x over, 4y equals negative 5x plus 7. Divide everything by 4. Y equals negative 5/4 x plus 7/4. Well, take a look. My slopes are the same. That means they're going to be parallel. That means that there's no solution. So substitution. Substitution is exactly what it sounds like. No, don't move that. I want this one. 1, get one of the variables by itself in one of the equations. Nice part is that's already done for us. The top one is got y by itself. Substitute what is equal there in for y in the other equation. Solve for the remaining variable. And then plug it back in and figure out what the first variable was. So here's what this looks like. Y equals all of this. So I'm going to put all of this in for y. So I'm going to have x plus 2, 1/2 x minus 18 equals 18. All right, so instead of this y, I put in all of this. So you get x plus x minus 9 equals 18. So this becomes 2x equals 27. So x is going to be equal to 13 and a half. So x is equal to 13 and a half. So now if I put that back in for x and figure out what y is. The good news is I can put it into whatever one I want, doesn't matter. So if I put this in here, I will get 1/2 times 13 and a half minus 18. So 13.5 divided by 2, or 13 and a half divided by 2 is 6.75 minus 18. So that's a negative 11 and 1/4. So that is my solution. You figured out x was 13 and a half, y was negative 11 and 1/4. That's my solution. So Matthew stopped for gasoline twice on a long car trip. Price of gasoline at the first station was $2.56. The second station was $2.65. Matthew bought a total of 36.1 gallons in gas and spent $94. How many gallons of gas did Matthew buy at the first gas station? First gas station. Okay, so here's what we got. Two variables. One, we'll call the first gas station. We'll call that X. So we'll call Y the second one. So now there's two pieces to this. One, he bought a total of 36.1. Two, he spent a total of $94. So X plus Y is 36.1. All right, so this is the gallons he bought at the first. This is the gallons he bought at the second. In total, that was 36.1. The second equation is this. At the first gas station, each gallon was $2.65. The second gas station, or sorry, switch that. This was $2.56. The second gas station was $2.65. And he spent exactly 94 bucks. So there's my two equations. So now I've got to solve it from here. So what I would do is take this one and get one of the variables by itself. So I'll subtract y. So x is equal to 36.1 minus y. Then once I do that, I'm going to put this in exactly for x down here, down on that one. So rewritten, it's going to be 2.56 times 36.1 minus y plus 2.65 y equals 94. So a little bit of algebra, a little bit of math. 2.56 times 31 or times 36.1 is 92.416 minus 2.56y plus 2.65y equals 94. This leaves me with 0.09y. And if I subtract 92.416 over, I get $94 minus 92.416. That's going to be equal to 1.584. A little division. So y is 17.6. So that means at the second gas station, he bought 17.6 gallons. All right, at the first gas station, how much did he buy? Well, if I take 36.1 minus 17.6, x is equal to 18.5. So at the first gas station, he bought 18.5 gallons. At the second gas station, he bought 17.6 gallons. So elimination. Elimination takes a few more steps. Elimination means, one, you've got to pick a variable that's hopefully by itself. that you can eliminate, what do you need to multiply the top equation by and the bottom equation by so that when you're done, the two equations are the same? Well, for this one, you don't need to do any of that, and I'll show you why. Then multiply the top and bottom by that number. Add the two equations together. And finally, see what you have left, solve it, go back and figure out what you've got. All right, so take a second, pause this, and write this down. Now, if you take a look at this system we have up here, I've already got positive 2y and negative 2y. They've already got the same coefficient. One is even positive, one is even negative. That's what I want. So I might have to manipulate this around a little bit to get that, but that is the end game. That is what I want. So here, I don't have to multiply the top or the top equation or the bottom equation by anything. All I want to do is actually add these two. So 4x and 2x is 6x. 2y plus a negative 2y is gone. 15 plus 9 is going to be 24. So look what I have left. 6x equals 24. Everybody can do 6x equals 24. X is just going to equal 4. So now put this back into either equation and figure out what you get. So if I do the bottom one, 2 times 4 minus 2y equals 9. So that's 8. So negative 2y is going to equal 1. So y is going to equal negative 1/2. So there's my answers. 4 and negative 1/2. So let's do this one more time. So this one we do have to manipulate. Now, which one's easier, x or y? I will tell you this. If I've got a variable with nothing in front of it, no coefficient in front of it, that's the one I want to go after. Okay, that's the one I want to go after. So I want to make this negative y look like positive 4y. So what I want to do is multiply just the bottom one by a negative 4. Okay, so I'm going to keep 2x minus 4y equals negative 26. I'm going to rewrite the second one as negative 12x plus 4y equals positive 96. So now add these two. 2 plus a negative 12 is negative 10x. Minus 4y plus 4y is 0. Negative 26 plus 96 is 70. So x is going to equal negative 7. So now take negative 7, put it into whatever equation you want and figure out what your answer is. I like the original one I had here. So 3 times negative 7 minus y equals negative 24. So add 21. So y equals 3. So my answer is negative 7, 3. Okay, last problem. All right, the practice at home, you purchase a basketball and a volleyball that costs a total of $67. The price of the basketball is $4 more than twice the cost of the volleyball. Find the price of each ball using a system of equations. Okay. So we have the basketball and we have the volleyball. So if we say the basketball, well, let's say the volleyball costs X. The basketball is $4 more than twice the cost of the volleyball. So the basketball is going to be 2X plus 4. So now you've got 2X plus 4 and you have X. And here's what they give you. They give you that both of them together add up to $67. So this becomes 3x plus 4 equals 67. 3x equals 63. So x is going to equal $21. So what does that mean? That means the volleyball is $21. Double the volleyball plus 4 is how much the basketball cost. So the volleyball is $21. The volleyball is going to be 42 plus 4, so the basketball is going to be $46. All right, that's all I got. So take your time, work through these, come talk to me with questions, make sure you guys can do this.